Welcome. My name is Karthik. I'm an Android engineer who works at Blue, and I've worked with several clients over the past 3 years, 3.5 years or so. And the following slides will include some logos. It's going to be sort of a quiz. So if you know what company that is, raise your hand. If you get it correctly, you win something. Let's see what you win. Got a few pins and badges over here and keyrings. Okay, first one. Oh, come on, raise your hands. Nobody gets nobody gets a prize. Next one. Some people might. Oh, of course you know. You're disqualified. Below people are disqualified.
Yeah.
Sorry. You raise your hand. That is an IB. I'll give you a prize later after our present. Okay, so he gets one prize. Next one. ABC. This one's slightly hard. AMP. Okay, this most people don't get. No? All right, bonus. If you get this one right, you get 2 prizes. I mean, same thing, but 2 times. That's all.
That's motivation.
Motivation. Because I've got Flutter pins, Google Cloud keyrings, Android keyring. So yeah, you could get 2 of these. Big stakes.
Trust your LinkedIn profile.
It's not on my LinkedIn profile. There are 2 more after this related to this one, which are on my LinkedIn profile. So if you want to just check it out, that's fine.
Can you give me a hint for this?
Think streaming, not Kafka. It is stream motion. You get 3 in total. Wow, that is stream motion. And if you don't know what stream motion is, they're the people behind KO and Binge apps. And now, of course not. The name is right there. They're the people behind Binge, KO, Flash, all these apps. Yeah, so I work across all these apps and clients in the past 3 years, 3.5 years, and each of them have a very different way of managing dependency. Each of their ways work for their project. And it's probably their own decision, their own way of how they want to manage dependencies across their organization, right? So my presentation is state of dependency management in Android Studio. And anyway, it's the state of dependency management in Android Studio. I'm going to talk about a few ways of how you do it. I'm not suggesting this is the best way or that's the worst way or whatever. But yeah, it'll give you a good idea of what is available to you, and you should be able to figure out what works best for your project. Or if you're starting a brand new project, you could maybe take one approach and build upon it. Essential question, what exactly is dependency management? As software developers, we often don't work in isolation with just our code. We work with a lot of source code, mostly open source code. And Android developers rely heavily on Square's open source code as well. And you need a way to be able to, get all these dependencies, manage them across your project. Often projects are multi-module. You often have projects which are using same dependencies across all the software in an organization. So these things, the dependency management and its policy becomes important as your infrastructure and as your app or your software grows. Okay, I already covered this. The importance is that you need to be able to scale it well so that it works best for all your software without really, getting conflicts, and you want to maintain the quality of your apps, and so on and so forth. You also want to consider the security of the application that you're producing. When I use the word application, I obviously mean software. I'm just used to developing applications, so I'm going to use the word application. That's too much application. Yeah, the security, it's very important these days. You can see how many data leaks and stuff is happening, and often the blame goes on a vendor dependency or a vendor implementation of something, not necessarily my own fault, right? So when you are managing dependencies, you would want to consider the security of your own app as well as that of the vendor so that it works out best for the end user. Performance, very, very important. If your dependency is extremely slow, it's going to eat up all the disk space or the processor speed, processor clocks, then why would you want to include it, right? So that's one of the important things you would want to consider when managing dependency. Code quality, the quality of the output that the dependency is producing, the quality of work that has gone in to produce that dependency. Uh, Easy enough to judge when with an open source software or an open source SDK. Quite hard to judge. You just have to take them on face value when a vendor says, "Yeah, my SDK is good. You have to trust me." And licensing. We know there are several kinds of open source licenses available, and often they include a clause that you need to declare, if you include this dependency in your software, you need to declare the fact that you've used this and this particular SDK, this particular dependency is bound by this and that license. So dependency management helps you, or the policies around dependency management help you structure all of this so that it's not a nightmare for you as a software developer or a project manager. Challenges. You often have conflicting dependencies, especially around transitive dependencies. If A refers to a certain version of B and C refers to an older version of B, and you include both A and C, then it causes conflicts, and you need to be able to resolve those. So versioning of dependencies is useful there. Versioning issues. Not everyone is great with versioning. Not everyone completely understands how important versioning is. No matter what kind of versioning you use, you go for X dot Y dot Z, the semantic kind, or whatever you prefer. Just understand the importance of versioning because it can make or break your product. Multiple environments. We don't just develop once and just deploy it, right? We have user testing environments, we have staging environments, we have feature builds, we have production environment, and we want all these dependencies to work perfectly on each of those. Often, a lot of dependencies have two variants in them. One is meant just for production and release. The other is meant more of a mock in stage or just a no operation dependency because everything that's going to happen is only meant for production. So yeah, dependency management can help you circumvent or manage these different states or different environments easily without having a lot of headache. Let's talk about state of dependency management in Android Studio. Dependencies in Android Studio are managed by the elephant. What's the elephant? Gradle. No prize for this. Okay. Dependency management in Android Studio is helped by Gradle because we use Gradle as a build system. It works as a repository fetching mechanism, for lack of better words, but this diagram kind of helps you. So when you create a Gradle build, it tries to look for the dependency coordinates to exist in the local repository. If it doesn't, it goes for the Gradle cache. If that doesn't, then it goes to the network and downloads the dependency from whichever remote repository it has to. It could be Google's remote repository, it could be Apache Maven, it could be any of those, not necessarily important for this item. And once that's fetched, it gets stored in the cache, and any future call to those coordinates will prefer to be get called from the cache so that it doesn't have to do another network fetch. A few methods for dependency management in Android Studio. This is something every new Android developer is familiar with and has dealt with the nightmare of it. Just manually implementing something. Just a full transparency thing, I'm only going to use Kotlin DSL as an example. I'm not going to use Groovy because Kotlin is nice. So this is how you would just declare or implement some library with the version number and the coordinates specified. It has some pros. It's really great if you're just building small application, just maybe one or two screens and don't necessarily want to fiddle around with the dependencies much. but it comes with a lot of cons. As the app scales, it becomes difficult to manage these dependencies. If you end up adding another module, you end up duplicating a lot of these because every module would have its own dependency, its own build.gradle, and then you've got limited flexibility there in order to, how do you manage these dependencies? You have to effectively manage dependencies better. You now have to approach any other method which does it easier for you. One of the popular ones is build source. Now, build source is a directory module within the Gradle build system itself, but it's not there already. But if you put it there, Gradle knows what it is. You don't have to do special stuff around it. And what it allows you to do is it allows you to declare objects in Kotlin with various values like this and constants like this. And then one more like this, where you can refer to a particular version number using the Kotlin's string formatting, and then comes with all the auto completion and everything. And once you have these two objects with their respective constants ready, you can just call implementation library object.mySpectacular as an example. So it'll figure out that, okay, I'm trying to get this particular dependency. And because it's a concatenated string, it'll also know the version number. Now, it can be a centralized way of managing your dependencies. You can have one build source and multiple modules in your Android project. And one build source with all these definitions can be reused everywhere within that same project. It's got great integration with Android Studio, does all the IntelliSense and all the auto completion for you. You can separate a lot of build logic within build source, and I'm going to come to that in a later slide. And like I said, reusability across modules. Got feature A, feature B, app module, multiple library modules. All of them can use build source. So you just have to declare it once and keep on using it wherever. It does come with a lot of build overheads because build source as a module gets built before any of the other module gets built. So this gets built, and then the output of this is applied to others, which means if you want to put something inside which is outside build source module, you really can't. And you have to wait for build source to build first. It comes with that kind of overhead. Any change within build source, like if you go from 1.2.3 to 1.2.4, requires a rebuild of the entire module. It doesn't just fetch that one particular library. And that's why it's slightly limited in scalability. There are ways to use build source across an organization. However, out of the box, it's not meant for that. It's meant for one project. So if you've got multiple projects, unless and until you create a submodule within your version controlling software, you won't be able to share that build source. And then with submoduling, it gets a bit tricky. How do you manage that submodule? How do you version that? So yeah, it's got limitations in scalability itself. Third one is version catalog, and this is the new hot topic in Android dependency management these days. Android Studio now has first-party support for version catalogs. The simple format is using a TOML file. Forgetting the full form.
Yeah, it's like his name.
Yeah, it's like his name.
Tom's object model language.
There you go, Tom's object model language. Thank you. And the syntax is pretty simple. You declare your version variables first, actually in any order, but what really matters is these headers. So within versions, you have the version variables or references, and you have your library definition references. Then you can bundle those libraries up together within the bundle section, and then finally the plugins you want to implement for your project. As an example, you would declare the version number of a library like this, following up with the library itself. So you would put the group first and the name of it and the version referring back to this. And in the implementation, it just goes in libs. You just use libs. That's the default reference for your TOML file. And then you can call the library name. Over here, you can use dash dot, and there's one more delimiter which I can't remember. All three of them are valid, but they all get converted into a dot when you're trying to reference them in the Gradle file itself. And pros, amazing integration with Android Studio. This can be shared across projects because this sits inside the Gradle folder itself. It's not necessarily part of a project, so you can share the Gradle folder across projects, and you get the beauty of version cataloging across projects. And it's faster because if you change one version, only that particular version gets fetched. The entire thing doesn't get rebuilt. It's not a module in itself which needs to be built. It's just a mechanism of storing coordinates. The cons is just a one-time con though. If you're migrating from something else, like a manual or build source-based versioning system, it's very boring and repetitive because you've got a lot of copy-paste to do. And it requires one-time upscaling. Version cataloging is pretty new in Android. Well, not exactly new in Android, but it's officially supported only this year. You could use it earlier as well. It's just now it's got out-of-box support in Android Studio, so not a lot of people know about it. So yeah, it would require some upscaling, especially if you've got junior devs who are starting out in the Android world. However, I think it's with Hedgehog, any new project comes with the TOML file already included. So Google has taken the stance that this is the way you should be going. Ooh, it's demo time already. Demos are here. Give me 2 minutes, I'll figure it out. I'll do the demos at the end while this boots up. Demos come with build comparison because I've got a table where I can benchmark all these different ways of doing things and gives you a nice table. So okay, we'll come back to this. Dependency updates. Now with dependency management, you would want to be able to effectively update your dependency when it becomes old, or if you need a new functionality, which is part of new shiny V2 version of that SDK, right? But you often don't get to know about it until you actually look it up, or you subscribe to a newsletter, or Android Studio tells you. So this is a plugin that I found to be slightly useful because it just generates a nice report, but doesn't necessarily force upgrades on you. You just implement it as a Gradle plugin and run. Yeah, it determines if your dependencies have an update. It's customizable with file tuning that I want to have alpha builds, I only want release builds, or things like that. It gives you formatted reports in different ways, JSON, TXT, HTML, XML, your choice, or all of them. And all you have to do is just run dependency updates as a task. The plugin comes with its own task. And I'll do a demo of this as well once my laptop is ready. And yeah, I'll show you the HTML report it generates and shows you, links you to the actual repository where it's available if you want to have a look. What's next after managing your dependencies? A couple of things which you can do for sharing your build logic itself, which is around declaring namespaces, min SDKs, release, signing configs, and things like that. Especially if you've got multiple modules, multiple library modules where a lot of these things are getting repeated, you can shove them across in your own plugins and just use that plugin across your modules. You don't have to rewrite it again and again. So in a way, it's dependency management, but for libraries. And the dependency is how do you build that library, essentially. You can also do that for app modules, but that'll be a separate plugin because they themselves use different plugins. One is for application, one is for library. So the two ways are Kotlin convention plugins and Gradle precompiled scripts. They do effectively the exact same thing. It's just that, in my experience, Kotlin convention plugins requires a little more boilerplate compared to precompiled scripts. The precompiled scripts, in a way, end up generating a convention plugin for you, but still requires some boilerplate. And I'll be doing a demo of this as well. Won't go to my last slide yet. Fire up Android Studio and soap demo gods are happy tonight.
Just check.
Don't have chicken. Yeah, everything seems to be working now.
Dependencies.
Just needed a restart. Good old, have you tried turning it off and on again? And only one guy suggested that. Everyone else was saying, use my laptop. The project manager of my current project said, just restart it. Thank you. See, it works since 96. I mean, that's what we do with our builds as well, right? Especially the cloud ones. Tear it down, run it again. Bear with me while I set up things here again. Android Studio.
Yeah.
Yeah. So I've got the main branch on here and got this nice little, is the text visible now? Yeah, okay. I've got this neat little script. What it does is it cleans the entire project, profiles and rerun all the tasks, and this just compiles the debug sources. And at the end of it, because I'm profiling it, it gives me an HTML report of how much time did the process take. There it is. What I'm going to do is, this is main. I'm going to take main as the baseline. It's a mix of not version cataloging, build source and some hard-coded stuff. So nothing fancy, just some random baseline. It has no meaning to it, other than the fact that this is a baseline against other branches. Okay, so SH benchmark. It is, however, I'm cleaning it and rerunning all the tasks. So
The tasks will still what's up.
yeah, the good thing is all the branches are fetching the exact same dependencies, just in different ways. The way have set this project up for demo is that I'm not fetching different versions of this same dependency. So there's parity over there. It's just different ways of storing them. Yeah. Okay, first profile for main. $16.469. It's a lot of it. 16.469. Okay. I'm going to switch. I'll just show it for transparency's sake. I've got some implementations as just hard-coded stuff, and as the project level, that's yeah. I've got them in build source over here. I'll give a better example with the actual branch. But yeah, this is just main. If I check out hard-coded. Okay, now everything here is just hard-coded. Nothing's in any of those build source files. Yeah. So if I run this benchmark on this one, okay, I think I know why the first one took so much time, because I had cleared the entire Gradle folder yesterday for my project. Anyway, hardcore, it should have taken more time than that. If I run the main branch again, it'll take slightly less than 7.43 seconds. You know what? It's fine, doesn't matter. 7.431. Okay. Still source time. I'm gonna sync it. And everything here, all the dependencies, even the libraries over here. Oh wait, not the libraries. All the dependencies here are declared in build source directory. And as an example, I've got versions inside this object as string constants. I've got libraries referring those string constants, often reading the version number itself. I've got a BOM as well, bill of materials, if you don't know what that is. And some of the Android config constants over here. Run the benchmark, it should be faster than 7 seconds, probably about 4.5 or so. Yep. Oh, okay. Less than 7. 6.879. And finally, version catalog. Okay. A quick sync. So inside your Gradle folder, you've got libs.versions.toml. That's the default name that you would want to use so that it just works out of the box. You can change it to whatever you want, but then you inside settings.gradle, you would have to declare that this is my toml file for version cataloging. But if you just use this name, it just recognizes it and starts using it. So I've got the versions here, exact same dependencies, exact same numbers. I've got all the libraries here. I've bundled the compose one because I still haven't figured out how to effectively include the BOM over here. I tried it, but it wasn't working. I was getting some error, so I never. This is using 8.4. It should have been fine. It wasn't. I didn't bother fixing it. Huh?
They did break both.
I believe it's. I was using 8.4 RC earlier. Now it's just pure 8.4, but I didn't bother checking it again. And yeah, just the plugins here. With the plugins though, there's a slight change on how you include plugins now. If I just show you the build or Gradle. So instead of ID, you just use an alias call. Essentially, can't see the source code, but what it does is it just fetches it from the version catalog provider and applies it for you. You can declare apply false here if you don't want it to be applied, but if it alias, you don't necessarily have to use apply anymore. There is another way of fetching them. You can just do this libs.plugins. Let's say Kotlin get. That gets the provider of that particular plugin, and then the plugin ID. And then if you want to use apply, you just use the same syntax as before. Anyway, I digress. Going back to benchmark. Okay, seemed like just a little over 4 seconds. 5.155, that's not bad. So you can see, like, if we consider this massive 16 and a half second build of main branch, should have been somewhere around 7 if there was Gradle cache in my computer already. But yeah, let's consider it this way right now. You can see hard-coded is faster than our baseline for some reason. Build source, however, is faster than hard-coded, but it does come with overheads. That's why version cataloging is much faster. But yeah, these percentages are when compared to main itself. So for a small project, gaining 68% in terms of speed, and it's a very tiny project, right? That's a massive number. So imagine if you scale it up to a multi-module project, you're saving a lot of time. Okay, I'm going to quickly move to the other demo that I wanted to show around convention plugins first. Before that, check out. Got 2 libraries set up in this branch, library 1 and library 2. They don't do anything. They're empty libraries. But the idea here is to show how do you effectively manage libraries using convention plugins. So this one is just how you would see in most projects. You've got their own build source where you declare the tool chains, the namespaces, configs, and their own dependencies. And library 2 is exactly the same. This library just exists. I haven't included it in the main project at all, just for demo's sake. So yeah, that's how it looks. This is the most common scenario you would see for library projects, and it's all based off the version catalog branch. Now, if I were to use convention plugins first, I can reduce all that boilerplate into just these 2 lines. Now, I created a convention plugin called convention Android library. I'll show you the source code in just a minute. And what it does is it takes all of that repeated code out into one place. And the only override I'm doing is for the namespace because I've got 2 different libraries, so 2 different namespaces. If you're not sure what namespace is, it's what was known as application ID, but it's now called namespace, and it automatically gets merged into the manifest later on. Okay. So for convention plugins, you will need to create this. You can put it in build source as well. However, the examples I've found use build logic, so I've kind of followed those examples. It is similar to build source, but you have to declare it because Gradle doesn't really know about it. So what you do is you include the build logic. So include build essentially tells Gradle that it's a build logic module. It's not necessarily an app or a library module. So treat it as such. It does end up generating a jar for you. It comes with its own settings on Gradle. So plugin management dependency resolution is its own piece. It doesn't use your project's stuff. And then this is just the build.gradle for build logic directory, the build logic module. And this time, the Kotlin and the Android Gradle plugins are dependencies. They're not plugins for the build logic thing because we want to use those to be able to create a plugin. So what we end up doing is using Gradle's DSL and its classes and the API, we declare something like this. What it essentially means is it's applying these 2 libraries in that plugin, and it's also configuring a lot of Kotlin stuff for us. Everything that you found in the other one is here, just a little bit more explicit. So we're applying the compile SDK value. We are declaring min SDK and everything. We're We're getting the release by name this time and then applying properties to it. And then we are manually adding implementations instead of calling the implementation API itself.
Just for extension function.
Today I learned. I didn't know about it. The implementation.
So if you replace add, you type implementation with parentheses.
Are you saying? So in string, right?
Any string, this extension function string. Parentheses.
See it.
No, that's the function. Click on the parentheses, you go to the extension.
Okay, got it. I'll implement it later and we'll probably open source it.
That's what the Gradle build script does doing anyway.
Yeah. Okay, coming back. I'll open source it. It's already open source though. Coming back, you can declare all sorts of plugins and extensions over here, and you can actually go at a very granular level. If you want to only do Kotlin stuff, you can make a separate extension for that. You can make a separate extension for Android library. You can make a separate extension for, let's say, detect if you're implementing that. Or you can modularize these and choose which gets included in which project. And then, like I showed earlier, your build.gradle file for the plugin, the library itself just becomes this small line with a small override of namespace. Everything else is in the plugin that I created. Same goes to the other one. The only difference is the namespace is different. But yeah, you still have to deal with all this boilerplate code, which looks a lot like Java, but this is Kotlin. If I go back to pre-compiled scripts, not go back, go to pre-compiled scripts. Compile script. Does something similar, except this time it goes inside build source. And these are the dependencies for the build source directory itself. It's similar to build logic because it's containing my build logic. But the Gradle API itself, the Android Gradle plugin and the Kotlin Gradle plugin are now dependencies. There's a new plugin that I implement called DSL precompiled script plugins, which gives me all the accessors and generators, which is going to generate a convention plugin for me. Source, precompiled. Okay. Now, the name of the file over here essentially becomes your plugin ID. So in this case, this is precompile-android-library. That's the new plugin that I've created. Pretty much the same thing, declaring plugins over here. And just, it feels as if you're writing the Kotlin DSL over here instead of Java. So it's easier to read, but as you can see, it's doing pretty much what we've done in that. And once this is compiled and built, somewhere, there you go. That's a convention plugin it created for me from that DSL. I'm not sure how it declares all of it, but it's probably using reflection over here and doing stuff. And then when I come to my library build.gradle files, I just call the precompile Android library from version.toml. I've declared them in my toml file. Yeah, there it is, precompile library. So it's got the ID, like I said. The version is unspecified because I've created this plugin. And yep, just declare them like the convention plugin because essentially it becomes a essential convention plugin. And I override the namespace. And that's pretty much it for convention plugins. So you can see how powerful it is, how it allows you to, break down each of these things into individual plugins in itself. I don't know if you've heard about it, but there's now an Android open source project on Google, on GitHub by Google. And they have very opinionated ways of how to do things. And they've actually broken it down into a lot of plugins. There's a separate Kotlin plugin, there's a separate library plugin, there's a separate Compose library plugin, there's a separate Compose something else plugin, I can't remember. But yeah, there's like 12 plugins over there which they can pick and choose to put in a library if needed. Yeah, stop sharing my screen here. Start sharing from here. That's it. Thank you. Questions, if any. Yes and no. I have used, well, not me in particular, but one of the teams in the project I'm working on has used version catalogs. It's now out there, part of production code base as well, but not production code base, but the one which is used to build production code base. And the project I'm working on, the team I'm involved with, we've just done a migration to build source before version catalog became out of the box solution in Android Studio. It's not merged into my master branch, main branch yet, so I'm going to convert it again to version catalogs because it's so much simpler, and then recreate a pull request there. Excuse me. Yep.
I've got a lot of different versions, Android, my IT stuff. Suggestions of benefits for different versions.
That's
So everybody does.
Yeah.
Our challenge is IoT is a little bit behind.
Yep. Yeah.
So we're still on version 7.
right.
And 9, 8. So any experience there?
Personally, no, not so much. So I probably won't be able to answer your question accurately. However, all of this is mostly meant for intelligent Gradle build systems, right? So if you're using that, using version terminals and exploring all the APIs around it might get you a solution. I'm not sure exactly how to answer your question.
IoT just migrated from your first straight.
Yeah, the hard-coded line.
Straight to version.
Mhm.
With Tom, just be really nice, like the studio would be like, okay, it's there, you know, that. But with Tom, I think like the plugins used to code.
Yes. Thanks for bringing me back to that, because I said I'll show you a demo for that. I'll do that now. But yeah, the Gradle dependencies, Gradle version plugin that I was talking about, I'll show you a demo. Irrespective of what way you use, it goes through the dependency lists and compares it to what's available based on my filters and shows a nice report. I'll do that at the end. And yeah, good job. And
also highlights which ones need updating.
yeah. The Tom file.
That depends on those in Android Studio because they keep moving into the alphas.
Yes.
I run Fairy, so I get a.
Yeah, it works the canaries, but then every time it goes to say, well, it breaks. So that.
Yeah.
But there is a plugin that uses that plugin that will actually rewrite the file with the versions.
Yeah, I saw that as well. I just didn't implement it. The plugin that I'm going to show, like I said, has a lot of plugins derived from it. And one of them, or actually a couple of them, what they do is they can update your terminal file, and they're specifically meant for terminal files to the latest stable version. Or you can, they can create a PR for that to get merged or anything. Something like Dependabot, but meant for Android Studio.
And what does work? Just putting it.
Dependabot, stupid. I'll share my screen here again and show that.
GitHub Actions. It's the.
Yeah. One sec. More questions in the meantime? Any other questions?
You mentioned about version.
I don't have an example for that, but yeah. I don't have any conflicting versions here, but what's your question?
Oh, how do you deal with that?
Just put them in a boxing ring and ask them to fight. Yeah, there's no straight answer to it, right? Like it depends on what functionality do you need and what trade-off you're trying to, what trade-off you're
I
able
guess
to
that you,
take.
like you want to pin like a transit.
Yeah.
Almost like a transit.
You could exclude, or you could write configuration rules where you force that if there's a transitive dependency, just use this version. Yeah, I probably should have covered that, but there are you can write Gradle rules for configurations. Okay, I'm going back to the version catalog example, and I'll just share my screen. Second. And it's now synced, and you can see in the versions itself, it's starting to show me that this version is outdated. That version is outdated. So you can obviously use the IntelliSense and code hinting over here to do that. But just to show you the plugin, goes to the entire dependency list, and it generates this. Where is it? Okay, it's in the build folder as per my configuration, and if I open it in Chrome, it gives me a list of dependencies. So according to the plugin, I'm not sure how accurate it is. These are on the latest milestone version. Gives you a link to the Sonatype repository of those. I would go to Sonatype for Android ones, I don't know. And these are the ones which are available to update, and also gives you a list of versions that I have implemented versus what's available. I haven't implemented any filters, so it's suggesting all the alphas and RCs as well. And it's also suggesting that I upgrade my Gradle from 8.5 to 8.4 to 8.5. However, it doesn't know that 8.5 is only RC right now, so this link is actually broken. Oh,
That's really
it's released. Wasn't released yesterday when I was checking it. It's released now.
I just did 8.4 last week.
Yeah, exactly. Yesterday it was 8.5 RC1. I'm like, okay. Yeah, thanks for pointing this out. I have to show this demo as well. Any other questions before I wrap up? Probably just one more. Yep.
Just on, so this thing you mentioned, this dependency. What techniques can dependencies?
So there are multiple tools, and the most common that I've heard from other developers is SonarQube. It does a comprehensive check of these things, and then often, at least in my project, the internal IT team, the cyber team, has a Nexus mirror, so they go through all of those by themselves, and they guarantee the security of dependencies. If they don't like something, they flag that particular version or they let us know. So it depends on company to company policy, but tools like SonarQube, you can implement it in your company's policies way, and
There was a Gradle plugin you can use. I'm just trying to, I've actually written a blog post about it, I can't remember the name of it.
yeah, maybe we can follow up later.
Yeah.
There was one quite slow.
Yeah,
Okay.
the other one is very slow. The other option is to you have to run a Gradle in a daemon plugin. It's not regular plugin.
I mean, it was great. Dependable is great if you're doing JS or something, but
No. So Dependable is what GitHub now uses for dependency scanning.
okay.
So if you're using GitHub Actions,
Yeah.
that's kind of your built-in dependency vulnerability scanner.
Yeah, but that still doesn't do a very good job with Android project platform.
It won't do the version number.
Right. Okay.
It only works in Groovy files. Gradle does have a plugin, but it's not incorporated into GitHub Actions.
Right.
They have a ticket. So
Somebody needs to just pick it up. Anyway,
The one
I-
I've got is the dependency check plugin by OWS.
and like you said, it's pretty slow.
Yeah, so
I don't have one. We depend on our cyber team.
Consensus.
We depend on our cyber team's Nexus repository mirror.